All right, this will be the first of two examples of us solving a quadratic application word problem. Our quadratic equation is located here, y equals negative 16x plus 20x plus 5. Since this first number, this coefficient, 16, is negative, notice that our u shape is going to be upside down. Everything that we had been working on pretty much beforehand, that first value was positive, so we had a positive u, meaning that the u was going up. This one is actually going to be coming down again because this is a negative in front of the 16. So you can kind of visualize this as the trajectory of some object being thrown, whether it's a baseball or football, how you're going to kind of throw it up in the air, and eventually with gravity, it's going to come back down. So with this information, things that we've been talking about already in the past few weeks, there are certain questions we can ask if this were something that really were to occur in real life. So the first thing would be, how high off the ground did the object start? Well, when you see this question, really what it's asking for is the y-intercept. If you're throwing a baseball or a football or some object, it's not starting on the ground. It's going to start in your hand, and more than likely you're standing tall. So in this situation, this person is more than likely 5 feet tall. So we can tell by this being a 5, this upside down U is going to intersect across the y-intercept of 5. That means that the starting height for this object was 5 feet. Not at 0 because it wasn't thrown from the ground. It was thrown starting at 5 feet. What is the highest point of the object? That's known as the vertex. Well, as we were dealing with our regular U-shapes, when this first coefficient was positive, the vertex is located at the bottom of the U. So that's where the vertex would be, which would be the smallest number. This is going to actually be the higher number here because now, since the U is upside down, it is located at the top. So when we come down here, we can see what these values are. We are looking at height, because that's what the question wants, the highest point. Again, height is on the y-axis, so we're looking at the second value. So it's not exactly 11 feet. It's a little bit higher than 11 feet at 11.25 feet, or 11 and a quarter feet. So it's 11.25 feet for the height, also known as the vertex. How high is the object 1 second into its flight? So if someone asks you how high something is off the ground at a certain point, what you're going to do is you're going to plug in whatever time they want. In this question, they want 1 second, and you're going to plug that in for the value. So if I were to plug 1 in for x, it'd be negative 16 times 1 squared plus 20 times 1 plus 5. And if you notice here, it says at 1 second, the bouquet in this situation that was thrown is going to be 9 feet tall. So it already hit its height at 11.25 and it started coming back down. It's going to be 9 feet still in the air, 9 feet away from hitting the ground. If we are able to look at that and you actually type it into a graphing calculator, you will see that when we type that in, when you put in a 1, negative 16 times 1 squared plus 21 times 1 plus 5, you are going to get 9. So any calculator you type that into, you type in correctly, it's going to tell you that that object's going to be at 9 feet. For our last question here, how many seconds does it take for the object to hit the ground? That's eventually when this object is done, it hits the ground, gravity has done its course. You can tell in this problem that the answer is going to be 1.464 seconds for that to occur. That would be the value that's located here. So if you were to type in this equation and you looked at this point in the graph, when you put the cursor on it, it would tell you that at 1.464 seconds, that object would hit the ground.